Hi, my name is Ahmed Jamshidifar. Today I'm going to solve some of the questions related to the frames and machines. Actually, we have a question here which asks us to find the components of the forces in pin A and B. And we have a structure like this, two pins over the ground and one pin over here. If you want to solve this problem, the first step is doing the free body diagram, meaning that we need to find the reactions at these points. But the thing is that if you consider these points as the pin which are connected to the ground, for each one of these guys you need to put two unknowns, meaning that for part A or point A, I need to put AY and AX, and also for B, I need to put BY and BX. And this means that for the whole, if I do the free body diagram of the whole system, I would have four unknowns when I have only three equations, as we did a lot of questions before. We have only sigma of x, sigma of y, and sigma m equal to 0, meaning that the number of equations and the number of unknowns is not matched. When you are facing such a problem, you need to take another look to the mechanism. You may have missed something. That could be like forgetting the idea of finding the two force members. If you look at this member, we have the conditions of two force member. What was that? That was like this. We need to have two connection points, which is like A and C here. We don't have any external forces or movement applied on this link, and also the components are massless. It's not mentioned in the question, but it can be assumed as long as they are not mentioning any weight for the links or any density for the links. We can assume that they are massless, meaning that this guy is a two force member. And the point of two force members is that instead of two unknowns, I can put one unknown here and say that because of having two force member here, I know the forces which is applied on point C and point A, and I know the direction of that, meaning that only the magnitude of that is one unknown, and in total we would have three unknowns. Okay, then I erase these things and try to show you how to do this question. I would say that I have a link or a member like this, which is A and C, and I'm pretty sure this is a two force member. As soon as I know this, I can say the forces which are applied on point A and point C are in the direction of the connecting line between them. Okay, meaning that whatever force is applied on A should be in this orientation, and whatever force is applied on C is in this orientation. And as you know, if we consider the free body diagram of the link BC, what we would have is something like this. We know there is a force with a known direction over there and two unknowns on the bottom side. I put them again, BY and BX, and I also put the distributed force on the right hand side. This is the distributed force which is applied from right to the left, and I have value for that. And you know, the reaction of the forces is applied on this direction. If I want to keep this guy in the equilibrium conditions and consider the moment around point B, these guys are starting rotating the whole structure counterclockwise, meaning that this guy should be like this. I just put this force direction, and I know the reaction of that is applied on point C, and because of that I need to have this on A. And if I get back to the original picture, I can put the force of A like this. I just put a force of A over there, and I know the direction of that, and right now I can solve this problem. As you can see, we have a triangle over here. This is 3, this is 4, this would be 5. Then I can write such a thing here, 3, 4, and because of the Pythagorean this would be 5. It's easy to do. 3 squared plus 4 squared, that would be 5, and you can do this right now. You can get back to the free body diagram of the whole system and solve these things, because you have only 3 equations and 3 unknowns, and the direction of A is known and the magnitude of that is unknown. Then the only thing which is unknown is Bx, By, and A, and these are 3 unknowns, and I have 3 equations. I don't want to spend time solving this. You can do that by yourself. I'm just trying to match the number of unknowns with the number of equations, and this is what I have done here. I have a similar problem here, which is very similar to the previous one. Actually, what we have here is the same question. We are looking for the forces at the pin A and B, and we have a link like this. If you start here and try to put the reactions without considering the possibility of having a 2 force member, you may put the Bx, By, and that makes some problems, meaning that the number of equations is less than the number of unknowns. But if you be careful, you can see that this is a 2 force member as well. We don't have any external forces or moment applied on this link, and this has only 2 connection points, meaning that instead of Bx and By, I just need to put 1B, and the direction of that is clear. It's going through this line, and I name it B, and as you can see, this is 3 equations as well. And if you just write down sigma fx and sigma fy and sigma m equal to 0, you can solve that. And just doing a review, we start with sigma m around A. If I do this, I would have just one unknown in the equation, and that's B, meaning that if you write down the equations, you can find the magnitude of force at B, and the direction is clear as shown. And then you can get back to sigma of x by having the B sigma of x or sigma of y and write them down. By solving sigma of x, you can get ax, and by solving sigma of y, you can get ay. And the key point is that starting from sigma m around A is helpful because it gets rid of these guys. They don't have any arm around this point, and that simplifies the problem. We find one unknown from one equation and then get back to the equations which each one of them has only one single unknown. This is the way that we are solving these kind of problems. Finding the 2 force members is critical. If you're facing with the problem like having more unknowns rather than the equation numbers, you need to get back and have a look at the diagram that you have and free body diagram that you have, and try to find 2 force members. That would be very helpful. Okay, this is another problem that I like to show you how to solve, and showing the effect of finding 2 force members. I have 2 other questions here. These are machines that we talked about them in the previous video, but here I am interested to solve one of them or two of them and show you how to find the relationships when you have a couple of pulleys and a couple of cables. As we said, for each cable we can say that the tension among the cable is the same, meaning that if I want to show you, this is one round of my cables, name it cable 1, and if I want to show the other one, I can use another color. The yellow one is the other loop, meaning that I named this guy, the tension of this guy, T1, and the other one T2, and right now I'm looking for two unknowns, only two unknowns. The thing here is that these guys, writing the equations for these guys is not so helpful because they're connected to the ground or to the ceiling, but writing down the equations for these guys is very helpful, meaning that we do free body diagrams for the moving pulleys. Okay, the pulleys which are moving, we are interested to do the free body diagram for them. The first one is this guy. If I put this guy over here, what's connected to that is this tension in the middle and two other tensions. I put T1 over here, T1 over here, and T1 over here. And in addition to that one, I have T2 over here. The other pulley, which is moving, is the huge pulley over there. And I have weight, which is connected in the middle, and I have three connected pulleys to that. Name this guy T2, this is T2 as well, and this is T2 as well. As you can see, we have two pulleys, and in the pulleys usually sigma fx and sigma m are not working, meaning that gives you 0 equal to 0. For example, if you do sigma fx, here is 0 equal to 0. Not working, right? Not useful. It's working, but it's not useful, right? Here the same story. The only equation which is working here and here is sigma fy, meaning that sigma m is not working as well. If you take the moment around the center, these guys are canceling out each other, and these guys are going through that point, meaning that would be 0 equal to 0. Then only writing down sigma fy is enough for these guys. I know I have 3 T1 positive minus T2 equal to 0, meaning that T2 is 3 times T1. This is the first equation. The other one is saying that you have 3T2 minus W is equal to 0. And if you do that, W would be 3T2. And if you get back here, T1 is the same as P, right? And we know that T1 is P. This is from the question, actually. And if you replace these things, I mean, if you replace P in T1 and T2 in this equation, what you get is W is 3 times 3 times P, which is 9 times P. And we know the weight of these guys is 9 times P, meaning that you can handle the weight of these guys with 1/9 of the weight. The force that you're applying is P, but the weight that you can handle is 9 times P, and that's the way that this machine is helping us to to handle or move up very heavy loads. Actually, this could be your hand, and you are almost 10 times of, you're applying 10 times of, almost 10 times of your maximum force, which can be exerted by your hand to this, and that would be a huge difference. But you need to do a lot, you need to do a lot of motion to bring this up, but that's not a big deal for you. You cannot increase the maximum force that you can apply on the cable, but you can wait and do a lot of work to bring this guy to the top. And that's the way that machines are making our life much easier. My last question is very similar to the previous one. You can see some other of these questions in the textbooks. I'm just trying to do this part red. This is my T1, name it P, because it's P, we know that. And then green for the second round, which is this, and also purple for the last round. As I said, you need to do the free body diagrams for the pulleys or moving part, and it's not necessary to go ahead with the connected the pulleys to the ceiling. If I do that for the pulley which is connected to point or pin A, I have P over here, one P in the middle, and the other P here. And the other thing I have here, name it T2 and T3. I have T2, and if I get to the other moving part, which is pulley of B, I would have T2, T2, and T2, and T3. And also, if I get back to the weight which I have here, what I would have is something like this: T3, T3 again. This is T2 and T2 again, and this is T1 and T1, which is P and P. Okay, right now I have three moving parts, including the pulleys and a weight. I can write down sigma of y for each one of them. As we mentioned, sigma of x and m are not working, but I have three equations for y direction for each one of them. And if you do these things, you can see that T2 is 3 times P, T3 is 3 times T2, actually T2, and you can see your weight is 2 times P plus 2 times T2 plus 2 times T3. If you replace from the top, I know that T3 is 3 times 3 times P, and I know that I can replace them from the top. That would be 2 times P, 2 times 3 times P plus 2 times 3 times 3 times P, and that means in total you would have 3 plus 6 plus 18 times P. That would be 26 times P, and as you can see, that's a huge difference. It can increase the maximum force that you can apply to handle a weight like this, and in total you can multiply your force by 26 if you use this mechanism. Okay, that was just doing some free body diagrams and solving some of the questions regarding the machines and frames. In the future video, I will try to show you some complicated problems regarding to the frames when we have a couple of connection points and a combination of the pulleys and the frames. Thank you so much. Bye.